Okay, so that is about which question? Question number 22nd. So now let us go for the next one. That is question number 23rd. So question number 23rd I will read. So question number 23rd is a uranium-238 nucleus decays by emitting alpha particle of speed, okay, V alpha I will take, is equal to V meter per second, like this. The recoil speed of the residual nucleus, that means alpha particle means along with that what and all things will be there. So I will just take like this, okay, uranium-238 mass is equal to, yes, you might be remembering, so recoiling takes place, right, 234 m, it recoils in this direction, plus what is there extra, what is there, alpha particle is there, right, so 4 m I will take, and what is that, so this will be having distance, okay, direction in that way. So if we apply this, that means initially before disintegration, conservation of momentum, recall nothing is there, 0. After disintegration, this becomes minus 234 m into V, right? So it is into V1 plus next what? 4 into m into V. Why V1 I have taken is just to V1 or okay V1 I will like this. So this one just V will take. Okay. So when you do the substitutions now, when you take that to left hand side, right hand side of the equation, 4m V is equal to 234 m V1, m cancels. So what we require here, we require what is V1. So answer will be, that is 4V divided by 234 it is. But in the option D, exact answer is D itself, but make a change there. 4V divided by 238 it is. Slightly you have to make a change there. Make it 234. Okay, so option is D. Which one is option? D is the option. Next, 24th question. Question is, a body of mass m1 moving with velocity 3 meter per second collides with another body at rest. Okay, let us see. So a body mass m1 with velocity 3 meter per second collides with another body at rest. So m2 initial velocity equal to 0, which is at rest. After collision, velocity of two bodies are, that means after collision they both are moving. Okay, first body actually having 2 meter per second. Second body is actually having how much? 5 meter per second respectively along the direction of motion of. This means, see, this question is about the elastic and inelastic collisions concept, conservation of momentum. Okay, that's why we are discussing this. So the ratio of m1 by m2. So m1 by m2 equal to how much? That is what you are supposed to find out. That is 24th question. So now diagram I have drawn there. So initially what you can understand, before collision, what is that? m1 into 3, m2 into 0, so leave it. Next, after collision, what is that? m1 into 2. Next, m2 into 5, correct? Next, what is the next step? We require m1 is to m2. That means m1 by m2 equal to, do the substitutions, you can take m1 into 2 to the left hand side, that becomes 1. So answer finally is, that is 5. 24th one, what is the answer? This is 5. Simple, but you have to be very careful while applying the conservation of momentum. Next, question number 25th question. Let us see the question. A body of mass 2 kg makes an elastic head-on collision with another at rest. Head-on collision. Okay, this was at rest, u equal to 0. Next, mass 2 kg, this is 2 kg, okay. Elastic collision, head-on collision with another body at rest, continues to move in the original direction with 1/4 of original speed. So after this one collision, no, if it was v, now it is v by 4 after collision. Mass of the second body which collides with the first body is, so if I take m, I'll take m2, m1. So they are asking m2 equal to how much? That is about the 25th question. 25th question, let us see how to solve. So now, to make it more easier, what I do is, I will just take v0, okay. So v0 I will take. Next, here what I do is v0 by 4 will take. And of course we know that is at rest, so just leave it. And finally when it starts moving, let us take it is moving with velocity v. So I think the diagram is clear for you. So velocity of the moving body before collision is v0. Collides with the body of velocity 0. After collision it moves with velocity of which one? v0 by 4. The another body which was at rest after collision moves with the velocity of v. So this is how I taken. Now I will apply what? The conservation of momentum. 2v0 equal to 2v0 by 4 plus m into v. So which one is m here? The other body, right? Because the first body in the question it is mentioned. So m2 I will take, because m1 they have given 2 kg in the question. Okay, you can read the question. Next, after that, m2 into v is equal to 3v0 divided by, what is that? 2 you will get soon after the substitution, correct? Next, after that, after the collision, no, what we can understand from this? Soon after collision, so before collision in the sense, what is that? We can understand m into v, that means mass into velocity of that particular body. So this much we get, but v you can find out now. How to find out that? That is, after the collision they start moving, right? With what velocity they will start moving? That means v0 by 4 plus v0. That means I am just adding a, okay, that means initially what is the total velocity with which the body has possessed? This one plus v plus 0, correct? Final plus initial, final plus initial, like that I got. So v is equal to 5v0 by 4 we will get. Okay, so m into v means what? We already know. So m into v means, just substitute what is v. So m into v is equal to 3v0 by 2. Substitute this v0 here. So this is 3 into 5v0 by 4. So when you start substituting that, finally what you get is, yes, what is that? The value will be the value of m, okay. So m v0 and all cancels. So finally what you get is m is equal to 1.2 kg. Do the substitution. I have it shown here, what and all equal. So you can utilize that, okay. Yes, sorry. So that is about the question number, which one? 25. I think it is clear for you. How we have taken is, initially body were there, collision takes place, just took the, what is that, conservation of momentum concept here. So before collision, after collision, like this I got. Then what I have done is, the total velocity before collision is asked for, that means first body and second body is conservation, right? That is why I have taken like this, just to, in order to substitute that, I got like this. So I think this is clear. Next, question number 26, and the question is, 3 point masses each of mass each of mass m are placed at the corners of equilateral triangle of side L. So like this, m, m, m of side L. Okay. Corners of equilateral triangle of side L. The moment of inertia of this system about axis along one side of the triangle. I will take axis along one side of the triangle like this. Okay. The axis I have taken in that way. But moment of inertia means you know, right? What is the formula for moment of inertia? M equal to m into r square. R means what? Distance from which the point we are supposed to find out. So this distance, that means how much it is from here to here. That means you have to find out what is the distance. Yes, this is root 3 by 2 into L, correct? Just by substituting. So what do you get here? So I is equal to mr square, right? So I is equal to m into. So what is that value? M into 3. Root 3 into L divided by 2 square. So answer is, yes, what you're going to get is, the answer will be, yes, 3 into m into L square by 4. Okay. So which is the option there? 26th one, 3 ml square by 4. Option B. So answer is B. Question number 27. So question number 27, what is that? A disk of mass m and radius r. Okay. The moment of inertia of the disk about an axis tangential to its edge in the plane of disk. Okay, like this. So this is passing through the center like this. So this will be the radius of the disk, mass m, correct? So what they're asking, the moment of inertia of disk about an axis tangential to its edge in the plane of the disk is. So here, why I am writing 1 1 here? From here to here, okay? I. That means here I have written, okay, not 1, sorry. I. So this is the moment of inertia. Through that particular axis I am supposed to find out. So how to find out that? So what I do is, I'll just apply the parallel, that means parallel, yes, you can see there, perpendicular axis theorem and parallel axis theorem is there, right, in this system of particles and rotational motion. So that is what I am going to apply here. So moment of inertia for parallel axis is given by, yes, what is that? You might be remembering the formulas what we have discussed in first PU concept. So that is along the diameter, center of mass, moment of inertia, center of mass along diameter plus mr square. You might be remembering this. Parallel axis theorem says like this. So we are just supposed to find out, yes, you might be remembering, disk means what is that? Center of mass along this one is 1 by 4 mr square plus mr square. Because this value is fixed value, you can by heart this one just by taking the tables for different geometrical shaped bodies and their axis of rotation through the center, through the that is parallel, parallel, this is plane, passing to the plane or through the center and all. So final answer is 5 by 4 mr square. So this is the answer. Okay. Next, let us go for the next question. Yes. Question number 28. Question is, uniform cylinder has a radius r and length L. If the moment of inertia of the cylinder about an axis passing through its center normal to the circular face. Cylinder is there like this. Like this. What has passed? Yes. Moment of inertia we are supposed to find it, alva. Then cylinder radius r, okay, this is radius r. Next, length of this cylinder is L, like this. Then here, if the moment of inertia of the cylinder is about an axis passing to the center and normal to its face, okay, this face, equal to moment of inertia of same cylinder about axis passing through its center and perpendicular to its length. So if a cylinder has radius r, length L, if a moment of inertia of the cylinder about an axis passing through its center and normal to its circular face, okay, is equal to the moment of inertia of the same cylinder passing through axis passing through its center and perpendicular to its length, then just we have to compare now. Okay, just they have given one condition. What happens if it is so means? Now what I do is, I'll just apply. That means moment of inertia for cylinder passing through center of mr square. That means basically if this is equal to, right now what's the condition? Passing through this perpendicular means this is m into, yes, what is that? These are by-hearted data. So in the sense you can learn this r square by 4 like this. Next, r square by 4 substitution I am doing. Okay, r square by 4 equal to L square divided by 12. Next, L equal to root 3, or by the substitution we have taken this. I think question is clear for you. Just they have given, if it is both are equal, then what is the relation between that? That is what I have written here. Okay. Next, 28th take down. Next, 29th question. Question number 29. And the question is, a solid sphere of mass m. Solid sphere is there. Radius also they have mentioned. Of mass m. Radius r, having moment of inertia about an axis passing through the center of mass, as I is recast, okay, into a disk of thickness t. Okay, the disk concept also they have given like this. A disk is there of thickness t into a disk of thickness t whose moment of inertia about an axis passing through its edge and perpendicular plane remains I. So that means its moment of inertia passing through its center and this moment of inertia passing through its center, they both remain, they have given it is equal to I. Okay. Then radius of the disk will be, so what they have given, a solid sphere of mass m, radius r, having moment of inertia about an axis passing through the center of mass and I, recast into disk of thickness. That means it only has become like what? Like a disk. For example, like while preparing the chapati and all, dough will be there, right? So when you compress that, what happens? It becomes in the shape of a disk. Same thing it's happening here also, okay? So you can see the diagram now. Now I can take this one as, I will take this one as smaller, okay? Or else r dash will take, okay? Yeah, r dash. That means radius has become much bigger now, right? That is why. So next, disk, radius of the disk you have to find out. That means newly formed disk is there, right? Its radius if you find out means that question is over. So now for that what I do is, I can take this one as r dash. So they have given initially their moment of inertia passing through center and all, it's one and the same. So this is, so you might be, you have to remember this, okay? Sorry. So mr square, right now it is disk, okay, this one means 5 is equal to, that means why this is 2 by 5 mr square, because you know this is actually the initially, yes, of course a solid disk is there, right? Next, what about this particular disk now? That means this is a sphere, sorry, half mr square plus mr square. Mass is one and the same, right? There is no losage, that means losing of mass, so let it be one and the same. So initially it was disk, its moment of inertia passing through the center along with, okay, like that we have taken. This sphere was compressed to make this, recast into a disk like this. Okay, so it has become disk now. So automatically the radius will become more. So what they have given, its axis, that means moment of inertia passing through axis is equivalent to this one. So that is why equivalent to that. That is why left hand side, right hand side of the equation has become like this. You can check the table where we can get all this. So now what you can get is, so by just substituting small r equal to, because they are asking what radius of the disk, this will be equal to 2r divided by square root of 15. Just do the substitutions, you will be good, because here r is common here also. You can just take to the left hand side, subtraction takes place, small r you can find out. So how we got all this? Because by using parallel axis theorem, we can find out moment of inertia of any object when it is given in the proper alignment. So for example, perpendicular axis theorem also you can use for different, and I think suppose you learn this formulas for different moment of inertia for different standard objects, in the sense like sphere, solid sphere, hollow sphere, disc, and ring, thereafter cylinder, hollow cylinder, solid cylinder, etc., triangle. Suppose you learn some set of things, no? This will be very helpful while solving the numericals. So I think this is clear for you. And let me go for the next last 30th question. And the question is, they have given like this. What is that? The moment of inertia of a rod about an axis passing through its center and perpendicular to its IO, that means moment of inertia. The rod is bent in the middle so that there is one rod like this. Okay. Rod is there. Passing through its center. Moment of, that means axis passing through its center like this. And perpendicular to its I0. That means, yes, of course, the moment of inertia passing through its center of mass. The rod is bent in the form of, okay, it's bent, okay, making an angle theta. So I will just write like here. It's bent like this. Later on, for an angle of theta. Okay. The moment of inertia of the bent rod about the same axis would be. So what we do is, we'll take. So here, this is the length. So entire length of this particular rod, correct? Here, this is the mass. Now here what happens? This becomes m by 2, L by 2. Because equality is bent, right? Mass also reduces to half. Length also reduces to half. Correct? So moment of inertia. What I do is, I will take. So here, so this is the axis of rotation, like this, and here axis of rotation is here. A I have written, you can see here, where I have written A, that is actually the axis of rotation. So now what I do, I will just find out moment of inertia of I1. This is I1, this is I2, separately, okay. So what is I1 now? So moment of inertia I1. So before that, what I do, moment of inertia of the just rod, Ia equal to just rod, because it's actually a by-hearted value, right? This is nothing but what? ml square by 12 equal to I0. Passing through its center. I0 they have given in the question, ml square by 12, because our memory. Okay, we have learnt already. Rod passing through center. Now individual I will find out here. What is the moment of inertia? So it is like this. So what we can do is, so this is actually 1 by, everything is like this. So suppose you start calculating this, what you are going to get is, so mass, that means is 1 by 3 m by 2 into L by 2 square. Inertia about this point. Okay. So the answer what you have to get is, that is I2 also like that you have to find out. This is ml square divided by 24 is equal to I1. That means I1, I2 both will give you the same value. So what is the last one? So therefore total, that means entire moment of inertia IA is equal to I1 plus I2. Okay. Like this. So total moment of inertia due to the rod because of the bending. So IA is equal to I1 plus I2. I think you understood that. So now what we can understand from this? So that is when you add up, ultimately what you get is ml square by 12 is equal to I0. I1, I2 you add. I1 also ml square by 24. This one also ml square by 24. That means what you have to understand from this is moment of inertia. Okay, you can write down moment of inertia is same for any value of theta. Just make a note. Okay. So that is how we have solved. So rod was there. When they have given that axis of rotation passing through the center, and I have given name A. And they didn't mention anything. They have mentioned only its moment of inertia is I0. But I have written ml square by 12. Why? Because we know that we have learned that in the table in the chapter system of particles. Then the same rod is bent like this in this shape, some angle theta. So once you start evaluating, right, I1 you will get like this because these are just direct values we can write down. So mass, this one 1 by 3 mr square. What is m by 2. R is how much? L by 2. It's 12. That is what. I2 same. So value we got. How much we are going to get here? I1 equal to I2. That is ml square by 24. So total moment of inertia is I1 plus I2, which is nothing but equivalent to I0. That means if you bend like this also for any of the angle theta, moment of inertia remains one and the same. So that is what I have written. Moment of inertia is same for any value of theta. So that is all about the 30th question. So I think today's topic, system of particles, rotational motion and circular motion. And regarding the conservation of momentum also, we have applied that. That means some of the questions I have mixed. Today's topic, I think this was very much informative for you. Well utilize this. Okay. So utilize the time at home. Do your best because time is very less now because next month there will be a competitive examination, right? All kind of competitive examinations are there. So fine then. Thank you.